Section 9.5 Energy in Chemical Reactions. Almost every chemical reaction involves a loss or gain of energy. To discuss energy change for a reaction, we look at the energy of the reactants before the reaction and the energy of the products after the reaction. Energy units for chemical reactions. The SI unit for energy is the joule. Often the unit of kilojoules is used to show the energy change in a reaction. 1 kilojoule equals 1,000 joules. Heat of reaction, or enthalpy change. The heat of reaction is the amount of heat absorbed or released during a reaction that takes place at constant pressure. A change of energy occurs as reactants interact, bonds break apart, and products form. We determine the heat of reaction, or the enthalpy change, symbol delta capital H, as the difference in the energy of the products and the reactants. Delta H equals the enthalpy of the product minus the enthalpy of the reactants. Exothermic reactions. In an exothermic reaction, exo means out, the energy of the products is lower than that of the reactants. This means that heat is released along with the products that form. Let's look at the equation for an exothermic reaction in which 185 kilojoules of heat is released when 1 mole of hydrogen and 1 mole of chlorine react to form 2 moles of hydrogen chloride. For an exothermic reaction, the heat of reaction can be written as one of the products. It's also written as a delta H with a negative sign. Exothermic heat released. H2 plus Cl2 yields 2 HCl plus 185 kilojoules of energy. Heat is the product. Delta H is negative 185 kilojoules. Endothermic reactions. In an endothermic reaction, endo means within, the energy of the products is higher than that of the reactants. Heat is required to convert the reactants to products. Let's look at the equation for the endothermic reaction in which 180 kilojoules of heat is needed to convert 1 mole of nitrogen and 1 mole of oxygen to 2 moles of nitrogen oxide. For an endothermic reaction, the heat of reaction can be written as one of the reactants. It can also be written as a delta H value with a positive sign. Endothermic, heat absorbed. Nitrogen gas plus oxygen gas plus 180 kilojoules of energy yields 2 moles of nitrogen oxide gas. Delta H is positive 180 kilojoules. Calculations of heat in reactions. The value of delta H refers to the heat change in kilojoules for each substance in the balanced equation of the reaction. Consider the following decomposition reaction. 2 moles of water break apart into 2 moles of hydrogen gas plus 1 mole of oxygen gas with an endothermic reaction of positive 572 kilojoules. Therefore, 2 moles of water plus 572 kilojoules of energy yields 2 moles of hydrogen gas plus 1 mole of oxygen gas. For this reaction, 572 kilojoules are absorbed by 2 moles of water to produce 2 moles of hydrogen and 1 mole of oxygen. We can write heat conversion factors for each substance in this reaction as follows. There's 572 kilojoules per 2 moles of water, 572 kilojoules per 2 moles of hydrogen gas, and 572 kilojoules per 1 mole of oxygen gas. Suppose in this reaction that 9 grams of water undergoes this reaction. We can calculate the heat as there's 9 grams of water and there's 18 grams of water in a mole, so it cancels, and there's 502 kilojoules for every 2 moles of water. That means that 9 grams of water require 143 kilojoules of energy.